All right, so 4.4 logarithm functions. And so up to this point, we've discussed exponential functions, and now it's time to talk about logarithm functions. And so if you remember our inverse functions, that's basically what logarithm functions are. They're just the inverse of exponential functions. So if you kind of look here, if you have f of x is equal to b to the power of x, and you're asked to find the inverse, well, you will convert this to y, and then we interchange, and then how do I solve for y? And so basically what happens here is the question mark is going to indicate that we do not have a method for solving this, to solve for y, to isolate the exponent. So a new notation called logarithmic notation is needed. The inverse function of the exponential function with the base b is called the logarithmic function with base b. Okay, so it's gonna. If you've never seen these before, you're gonna be kind of taken back. But just give it a minute. Basically, all it's gonna be about is helping us solve for exponents. And so I'll give you a real easy example, real quick. So like if I had something like 8 equals 2 to the power of, and we'll call it y or x, whatever you want to call it, and so my answer would be 3, right? But sometimes they're going to be a little bit messier than that. What if instead it was 10 equals 2 to the power of whatever y? You might be able to come up with a good guess, but anyways, that's where these logarithm functions are going to come in. So let's go ahead and look at some of this down here. So the definition of a logarithmic function, these are the two pieces that need to hold. Our x value needs to be greater than 0, okay? And the base needs to be greater than 0, but also it can't equal 1. So right here, so y equals log, you'll have your base b, x, and then equals y. And so what this converts into as an exponent form is b to the power of y equals x. So going back to this example up here, so if you had something like log base 2 of 8, so the answer is 3, because what this is asking you is 2 to what power gives you this value right here. That's all it is. Just saying 2 to what power gives me 8, and so this answer would just be 3. So a lot of times what we'll do, though, to kind of avoid some confusion is we'll actually switch it to exponential form right here. And sometimes we'll actually go and take this form and convert it to log form. So sometimes we're going to go back and forth. And so that's what we're about to practice in a second. And that's it. We're not actually going to start solving just yet or simplifying any of these. We're just actually going to practice converting back and forth. And so here's a little diagram right here that might help you remember how to convert this. So if you're in log form, just you can kind of do a little clockwise little rotation here. So b to the power of y equals x. So this is something that you have to have down for this unit right here. Okay, this is big. Okay, and we're going to go both ways. We're going to start with logs and convert them to exponential, and the second we'll have to take these and convert them back to logs. So looking at these first couple examples right here, we're not actually solving yet. We're just going to go ahead and do our conversions. So right here, this is going to be 2 to the power of 4 equals 16. And yeah, that's true, but I don't even need to solve it right now. This is just practicing our conversions. Okay, so then this is going to be 3 to the power of 2 equals x. That's it, just leave it like that for now. Here, this is going to be, let's see, b to the power of 5 equals 32. And this one, they're trying to throw us off by kind of writing it by switching the two sides or whatever. But it's the same idea. This is going to be my base, 6. This guy over here is the exponent that you're trying to solve for typically. And then equals the value right here. Okay? And so before these calculators, what a lot of math books would have for these logarithms is they'd have a table that you'd have to kind of look this stuff up in. So if you wanted to know the answer to this, you'd look in a table, and There'd be a column for, your B values right here, and then there'd be a row going across for your different, X values that would be right here. And so you'd actually have to go thumb through a table and find these answers. And but we'll be able to use the calculators to help us, so we don't have to look it up in an index. So we'll see that at some point in this unit. Okay, so now what we're going to do is we're going to go, once again, just kind of practicing these two forms. We're going to take the exponential form and convert it back to a log form. All right, so I'm going to scroll down. Okay. So just if you kind of remember, your exponent is at the top, it's all alone. That's your loner. Okay, the other two pieces are going to go together. And so your base just stays your base. So this is going to be log base 2, and then this guy goes with it right here. And then that power that's way up here, just put them on the other side. There you go. So that's our conversion right there. So whatever little trick's going to help you remember this. Do it enough times, the muscle memory will kick in. It's fine. So if you go back up to the definition, it did say that our values need to be, the X and the B value need to be positive, but it didn't say anything about Y, your result. Okay, so it is possible to get negative results, and so I just want to point that out because you're going to see it on this next one. Because we do have a negative value, but that's okay because it's our result. And so what this is log base 2 of 1 over 16 equals -4. So it's okay for this, your result, to be negative. These two values right here have to stay positive. All right, so then this one right here, let's see, this is going to be log base 13 of x equals 2. That's it. Okay. All right, coming down here, so this is going to be log base b of 1,000 equals 3. And then this next one's going to be log base 7 of 200 equals y. And that's it. All right, so moving on. We're going to start to evaluate some of these expressions without a calculator. And so I'm going to go ahead and write down our conversion again. And a lot of times that can kind of help you out here. So if you have log base b of x equals y, that converts to b to the power of y equals x. And so, I mean, you don't have to do this, but it kind of helps students, because what's going on is what they're asking is 4 to what power equals 16. And so if you want to, you can go ahead and set this up kind of like this and just put an equals y on it. Yeah, what does this equal? And then you can do your conversion. You can be like, okay, 4 to the power of y equals 16. And then from here, well, you can just do this in your head, so without a calculator. So that would be a 2. So that's your result here. That's your answer. That's what this simplifies into. And so we can just kind of continue this as we go down. And they'll start to get a little bit more complicated, but we should have the skill set to solve these. Some of the stuff, it might take a little bit of time to recall, but anyways. So this next one, let's see, so that would convert to 2 to what power gives us 64. Now that's a little bit bigger, right? So you might be playing a guessing game. So what you might want to do is come over here and just start multiplying 2's together and see what happens. So that would give us a 4. Then if I multiply by 2 again, 8. Multiply by 2 again, 16. Multiply by 2 again, 32. Multiply by 2 again, 64. So let me see, how many did that take? So let's see, that took 1, 2, 3, 4, 5, 6. So it took me multiplying 2 together to itself 6 times. And so that's what the exponent power would be there. So 2 to the 6th power, 64, and we're done. Okay, so like I said, we're going to start getting into some that a little bit more interesting. So right here, 5 to what power would give me 1/5? So if you want to, you could pause and try to think about it and figure it out. But hopefully you remember your properties of exponents, because we're going to be using them moving forward here. The answer should be -1. Okay, so a negative exponent causes you to reciprocate, and so there you go, 1/5. All right. So as I work these out, I'm not going to really pause to give you time, but if you want to, I would pause the video and maybe think about it and try to come up with the answer before I give it. Okay, so right here, once again, I'm going to kind of play this game so I can convert it and say, okay, 2 to what power would give me 1/8? Well, kind of like the last one, apparently, caused me to take a reciprocal to turn into a fraction, and then that 2 turns to an 8, so the answer is -3. Okay, and so if you want to, you can try it off to the side of your paper. You can, okay, yeah, take the reciprocal, and then 2 to the 3rd power, sure enough, 8, so 1/8. Okay, so then our next one, let's see, so once again, we'll kind of set this up. So 7 to what power gives me the square root of 7? Okay, so this might be something that you don't really recall. Oops, getting a little messy there. But this is actually gonna, it does deal with our properties of exponents, but it also deals with radicals, and you got to remember the conversion. And so this is actually deals with rational exponents. And so rational exponents, just fractional exponents. So here's a conversion that we're going to use here, and something that you'll actually see later on in the unit. So if you have the, we'll call it the a root of some number raised to a power of, let's just call it b. Okay, that converts to that number being, oops, oops. Okay, sorry about that. That froze up on me. So there's the conversion. So if you're taking the a root of some number raised to a power b, that would convert to n raised to the power of b over a. So that right there. So if you look right here, whenever you take square roots, it's understood as being you have an understood 2 power right here, and we have an understood 1 power right there. So what's going on here is this would convert to 7 raised to the 1/2, right? So then 7 to what power would give me 7 to the 1/2? Well, right there, you should get just 1/2. So let's look at our next one, which will have a little bit of all these elements we've seen thus far. So let's see, set that equal to y. So we're wondering 2 to what power is going to give us 1 over the square root of 2. So there's 2 things in play. You've got the radical, so you know you're probably going to have a 1/2, right? Kind of like the previous one. And then you can see that it reciprocates, and so it's going to have both of those elements, so it's -1/2 is the result for that one. So if you raise to -1/2, you'll flip, and then raising to the power of 1/2 is the same thing as square rooting. So there you go. All right, I just have a couple more down here. So let's see, we'll set this equal to y. So let's see, we'll say 64, some power y, equals 8. And actually, we're still kind of in the vein from up above about radicals. So that's what that's going to be. That's just going to be 1/2. Okay? Because if you raise 64 to 1/2, that's the same thing as taking the square root, right? And the square root of 64 is 8 right there. Okay, these last couple should be fairly straightforward. So if we look right here, so we'll set this equal to y. So this converts to 5 to the power of y equals 5. Well, that's kind of silly. That should just be a 1, right? So 5 to the power of 1 would equal 5. Next one, let's see, we'll set this equal to y, so we'll convert it. So 4 to some power y equals 1. Once again, you're going to have to reach back and think about your properties of exponents. Okay? And so any number, as long as that number is not 0, any number raised to 0 is going to equal 1. And so that's what our exponent's going to have to be, is 0. There you go. Okay, these last two are going to be, the first one's probably not too tricky, but the very last one's a little tricky. And we actually have a property for it that we can look at down below right here. But first, I just kind of want to show you, let's say I didn't know the property, okay? So once again, I could just kind of be like, okay, I don't know, this equals y, right? So you take this, the base right here, and you'll say 5 to this power equals this part right here, which is going to be 5 to the power of 7. Okay, and so, okay, 5 to what power would give me 5 to the 7th power? Well, that must mean y is a 7 right there. So there you go. So that one wasn't too bad, and so you can see that property right here. Okay, so if the base matches what you're evaluating, then the result's going to be the exponent right there. And I think we kind of had one like that actually right here. Because see, this has an understood power of 1 right here. And so that's what our answer ended up being on 35. So, okay, the next one might be a little bit more harder to grasp, but we'll look at it. What we're going to do here instead is let's look at. I'm going to write down the conversion again real quick. So let's see. Log base b of x equals y is the same thing as b to the power of y equals x. So this is actually already an exponential form. So a lot of times, if you're having a hard time with something, you'll switch it back and forth between the two different forms. And so right now I'm in this form right here, so I'm going to go ahead and set this equal to, I guess, x in this case, because I'm matching this formula right here. And I'm going to rewrite it into this format right here, okay? So this is my b value right there, okay? That's my b value. So I'm going to rewrite that as log base 8, okay? Okay, so the exponent is going to be the power, it's going to be on the other side, the equal sign, so it's going to be over here, okay? And then you can see where the x is supposed to go. So I'm just going to go ahead and put the x here, and then equals, it's supposed to equal this exponent. The exponent is interesting because it's the log, okay? So log, oops. Okay, picking up where I left off. Sorry, this thing's going to probably continue to give me problems, but anyways, we'll deal with it. Okay, so log base 8 of 19. So took the base, put it here, took what it was equal to. That's what I evaluate right here, and then it equals the exponent. So if you compare the two, everything's the same except here I have an x, here they have a 19. That must be what x is, and that must be what this simplifies into is just 19. And so once again, we have that as a property right here. So log base b of x. So if the base matches your exponent log base, it's going to equal what's being evaluated right there as part of the log rhythm. And so there you go. All right, so that's going to be part 1, and I'm going to make a separate video for part 2.